Hello once again, my good friends. It's Roger, Mud Fossil University, and today we are going to confront the allegations that Mud Fossil University makes allegations without facts. So, the facts that I will present are so voluminous that it's almost embarrassing to have to bring forth this much evidence against so little counter evidence, to the point of literally none. So let's see what we got. Okay, before we go too much further into this, I just want to say make sure that you subscribe to this and click the little bell wherever that happens to be, so that you get the updates and come out and see what we've got going on. And I'm going to have Mud Fossil Memoirs, which is the whole history of how this happened and how it developed and why we discovered this and thought about that and so forth. It's very interesting. And then we go into these walls and Atlantis and all of that stuff, new species, why PhDs don't pay any attention. So let's go into it. And at the very end of this video, there'll be a full chemical analysis showing the concentrations in sandstone and mudstone and limestone. The different, it's a chemistry lesson. So that'll be at the very end. And these, you should go out here and look into this. Go up and catch up a few of these. Mud Fossil University explains biology of geology. Did pliable stone build the ancient world? Megalithic seamless structures. It's a fossilized exquisite heart, which they fossilize in blood. Mud fossil. And then we go into some of the physics and unexplained new species and all of this. So come up here and get involved and start to learn the reality of what's being ignored, because it's very simple stuff to understand. And if you don't feel as I'm correct, one of the things that we're saying, go somewhere else. It's fine. But if you don't see this, then you really have no way to assess whether what you have been told is correct or not. I guarantee you it was not. All right, you see this here? This is what they call granite. And it is not, it's not natural. They call it granite, that's fine. But there's two different types of granites. There's a natural one, and then there's this, which is crushed rock that was mined for the metals. And this is the only tiny little piece of metal I could find in 30 feet of countertop. And I know this because this is in my house, and it is black, is the vein blood that's all crushed up. You see the little black bits and pieces? Then this is the red, is the arterial network, and then this, you see this white, chunky looking stuff? That's the connective tissues. All right, so this is not something that I'm guessing at. I can tell you for a fact that is exactly what this is, and this is not a natural product. All right, so I'm going to show you what a natural granite is. Because they all have metals in it. If it's natural, it has metals. It is not granular in chunks like this. All right, whole different issue. This is granite, but not that kind of granite. This you can find veins and arteries, and you can see your red and your black and all of that business in here. That is a natural stone, but that obviously it's a creature that has petrified. But this, I believe, is natural. Now, there's marble and so forth. If there's no metals in it, it's not natural. Now, if I could go there and see this and look at this, I can see the structure of anatomy and biology if it is in there. This could be byproduct as well. And it just happened to have this kind of a mess to it as it was laid down, but I don't think so. This looks natural to me. All right, this is a paper I did a while back on granite, and it's recrystallized crushed stone after the metals were removed. Now, it goes on here, and then I can show an Olmec head that they actually were molding. A giant was molding it. It's not something they carved out of it. Basalt, it is the type of material I'm talking about, granite, which is not natural. Now, then I talk about what is basalt, and then I talk about what is granite. And well, this is the worldwide average of the chemical composition of granite. Silicon, da 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 da. Why is there no precious metals? There's no precious metals, none, zero. They did alchemy long ago. They took out all the precious metals, and then they put them in piles. And they are the platinum group electrum they took out of it. And I have the platinum group electrum that I have found in mud fossils. And it is it's something that is a product of creatures in real granite. The electrum collects, not in the granite there, the crushed up rock granite. You don't see it because they remove it. All right, I'm going to just show you some more of the anatomical details, the biological things that we will see in geology. And they call them foliations of the earth. They already even call them sinuous and all of the different. They're exactly identical to muscle tissue and tendons. Now, these are the fibrils you will see all around the earth. Giant's Causeway, Devil's Tower, all of that. They're hexagon-shaped calcium carbonates, which are the tendinous materials, and they are shielded around by what's called fascia. And that is a coating of a little slippery kaolin clay. It's called synovial sheath, and it has a bloody, rusty-looking color to it. Very, very, very thin, but it separates every fiber from every other fiber. That's how everything in you can move back and forth and twist and all that. Otherwise, you would be a block of stone. Literally, that's a fact. That is stone. However, it's configured in such a manner, and it's in such an aqueous solution that it's flexible, and that's what your tendon does. Although it is strong as hell, and it is tight, and it is under tension, and that's why you see at the top of Devil's Tower, excuse me, they have wrinkle zones on every time. All of the fibers that you see that have the flat top, where these are, you'll see there'll be a wrinkle zone where it broke at the very top, because then it goes, it loses its tension, and it just it shrinks up a short distance, and it's all wrinkly. And I'll show you that. All right, see that's the wrinkle zone up at the top, and you see this reddish looking rusty color. That is the blood. That's the arterial blood that services it. And it actually, it's so thin you can't really see it, but it's a coating on it. It's like a little plastic coating of every one of those fibrils, which I just showed you in the tendon fibrils. And my claim is that that's a foot, and I can easily show that that's a foot if you look at the structure of the heel of a foot. That is the calcaneus area. This is the abrupt transition. They break flat as a pancake. That is the wrinkle zone at the top of the tendon fibrils. This surrounds the ankle bone, really, because that is the structural support that allows you to walk, and you have a spring in your step, and that's literally true. That is the spring in your step. You see that dreamtime.com? That's the same thing. That's the wrinkle zone. And each one of these was a fiber. Now, when this was not broken at the top, this was stretched tight as a rubber band, and when it snapped, bing, it goes like that. Now, when they were wet and soggy, they were mining these things, and I will show you that. All right, I'm not sure where this picture came from, but it is in Peru, I believe, and these are the structure of some obvious vehicle that was here, and it had more or less tank treads that sat on the soft surface and kept it from sinking in, and these were the vehicle tires that you use on the road and sink a little bit into this, and they can just drive on this, and I'm sure the tire things went just like a tank does. Now, this here you can see is slabs of this wet material. When it was wet, was being removed by this particular device, and you can see it runs all up and down. I'll show you a different shot of that. I had a lot of videos on these things, and again, I don't know where these came from. People send them to me, or I just got them on the web, but I've investigated them, and this is true. This is here, and this is a tendon, and that is the slabs of chunks being cut off it, and that's how they made these walls that they fit together, and nothing can be fit in between them. They were like chunks of putty, and they were wet at one time after the flood receded and all the creatures were dead, and these were the giant creatures. And I mean, I'm talking giant. There was no little 18, 20-foot puppy creatures laying around. Well, there was some of those too, but these are the ones that Enoch talked about in the Bible. They always thought it was a joke. Miles tall. Well, it's not a joke. It's reality. All right, let's go on to the stone balls from tendons. These are the stone balls you see all over the world. That cutout right there was what that was supposed to be embedded in. They're embedded into just above the edge of the, as it curves in, so it holds, it's called a tuberosity. Now, from that tuberosity, there is a Chinese finger trap, which is part of this tendon mat assembly. That stalk, which attaches to the tendon ball and is a different material, comes back to here and embeds in the tendon mat, and there are numbers of these, many dozens of them in each one of the tendon assemblies to hold that mat or the tendon balls or the bones and the muscles in place so they don't rip out. This one ripped out, that's going to be painful. Now, the tendon walls that I just showed you down in Peru and so forth, some of them are made from these mats, which is not the ones I just showed you. The other ones were made from Achilles tendons. This is a different type of tendon material, and it's a mat that is like maybe go on your stomach or that type of thing. It's a flat mat. Now, these stalks, they break right off here. I mean, there's what they call abrupt transitions on going from here into here, and then towards the ends there's a bunch of transitions. Now, they break these little tips off, and then they cut these across, and they use these flat as the walls, and you can see those in down in South America as well. Now I'll show you a little bit more about this because they come quite large. Now remember this particular strap here going down to this particular ball here. Now if some of this eroded away, I'm going to show you what you could possibly end up with. Alright, you see what you got here? That's a tendon strap. That is one of those tendon balls. This is what the mat was right here. There was another one here. There's another one down here. There's another over here. They're all over the place. That's what happens. And here I'm going to show you what the cluster looks like in a creature that, as it grows in the anatomical drawing. Because this is all fits exactly anatomically identical to what is seen in biology. And the chemistry is correct. The materials, the metals, the minerals, the fibers, the structures, the anatomy, it's all 100% correct. All right, these are the abrupt transition on those tendon balls. That's the ball, and the fiber, of course, went way out, and then they normally will break right here in certain conditions. They normally do. Rarely do they continue to stay attached as seen in that enormous one. They are everywhere on Earth, these tendon balls, and they are in enormous quantities and coming out of the Great Lakes in clusters. And that's because they grow in clusters, and they are in every single tendon and every single ligament in your body. Ligaments attach bone to bone, tendons attach bone to muscle, and muscle to muscle, and they strap your body and so forth. This is the structural components, the tendons and the ligaments that hold you in together. Now, they are strong, they're tough, they're made of calcium, CaCO3, and other minerals and metals that do this particular job. Very specific, and I have all the chemistry. I've done this very carefully, and I have all the samples to show this, and I'm doing a study on what different materials and metals collect in what different locations of different emphasis points, and what about its shoulders and versus to toes, and there's a difference. So anyway, this is the type of different chemistry as the balls grow and in different places and different manners. All right, this is what happens in the mud fossils when they stand in the mud and they drown or starve or whatever happens to them, but their feet are stuck in the mud. Usually one is in the mud and one is out. One is deep, you can't see it, and one is up above, like trying to push themselves out. That's what it appears to be. Sometimes there's two right on the surface. Now, this is the wrinkle zone at the top where the tendon breaks off as the body falls over once it dried out. And it snaps off exactly flat as a pancake. It's called an abrupt transition. Very, very, it's fully understood. Now, above that, the red muscle material and the fleshy stuff erodes. This will turn into blocks of little stumps and stones laying around, all at the base of the foot. And that's what Devil's Tower is. All right, I believe these, I'm not sure actually, to be honest with you, but I'm pretty sure this is coming out of the Great Lakes. I'm getting large quantities of people sending me things, and I believe they're coming from that region because I've been discussing it. A lot of people don't put any locations where they come from, so, but they are obviously these stone balls, and they are obviously the stone balls I've been talking about. It's another one sent to me. You can see they have these layers, and they are then the stalk would have been going from right out of here. Now, these are also the trovons. The trovons are this exact same material, only it's been petrified in a different condition, or the conditions that exist in that area have some kind of an acid or caustic which causes this to oxidize and grow and scale and increase in size and look as if it's actually expanding and growing, which it is, because it's rusting, really, is what it amounts to, just like rust. Rust, you realize, when you have iron and it rusts, the expansion is 10 times greater than what it originally was. So if you had a tenth of an inch of steel was replaced, it would be 1 inch thicker now. So it shows up like it's growing. That's what the trovont is. And it's these things, the enthesis tendons, tendon enthesis balls. Now, certain conditions where the center is made out of like sand. I believe it is actually sand. I haven't actually done the analysis on it, but it appears to be. And this also is the layer that is on the outside, and that I believe is chert, flint type material. And that I cannot swear to either, but this is stuff that needs to be tested, and I don't have the facilities to test this, and I've done all the testing I'm going to do because everything I've ever done has been ignored. All right, there's another cluster of these stone balls. You can see where the things attached to all of them, basically, and they would have held something, some form of flesh, into a stomach muscle or an arm or a shoulder or a bone. That is what it is. It's all there is to it, and that's a house and that's a car. All right, Gary Evans found this in a mud flat over there in England after working with we've been working with him with the mud fossils, and he went out and he looked, and sure enough, bang, pulled one of these out. I mean, you can see the blood in here, and you see the black blood in that? That's the blood that is returning to become oxygenated and turn red. Black in the mud fossils is blue, is like blue in the in a normal anatomy. Your blood, what happens is if you don't understand, most people understand this, but I'm just going to say it if you don't understand. Your lungs put oxygen into the blood. When you put oxygen into the blood, it's called FeO2 blood, is the black blood coming back. It throws another oxygen on there. You got FeO3. That is the red blood, and it turns real red blood, real red. And then zip, it goes through, well, you can see it. And then it sends that stuff down through unrestricted tubing. So it goes to every little bit and piece of your body, everywhere. And it's unrestricted, so you cut one of those, they keep pumping forever. That's why they got to cut them, tie them off. Now, or sew them up good. Now, the vein is totally different. The vein is the suction device. It's the black hole of the body, and it may be the black hole of the universe. And it sucks all that blood up through the arterial passageways that have expended the blood. And by the time it gets over to the vein, which is the vacuum cleaner, it's a dark blue, or it's a blue. And when it's more oxygen in the mud fossils, it turns black. So that's the nature of the biology of geology, and it's got to be looked at in a more open-minded light. And don't run from it. It's nothing to hide from. It's just facts. No reason to hide from it. Well, I mean, you know, you're only going to look worse if you keep hiding from it. Let me put it that way. Okay, every person that's been paying attention to the mud fossils obviously is going to see this and have absolutely no question what they're seeing. This is the layering of flesh. That is what happens in flesh. It layers in these different patterns. What also happens in flesh is it needs to be fed with red blood, and it needs to have the vein blood picked back up. The red blood is here. The black blood is here. They are picking the black blood out with the pick because it is hard and it collects in the veins. The red blood is very soft, and I don't think they bother removing that. But you can see that this is exactly what I am discussing here. That is the arterial blood that feeds and services this synovial sheathing and the nutrients. And the black blood over here is the vein blood, which is being slurped back up to the lungs to be reoxygenated, to be pumped back to here. These are not layers of sedimentation or anything like that. Those are layers of biology. And that is the salt mines underneath the Great Lakes. All right, you can see that these are very similar looking, and it could be totally just a coincidence, but I don't think it is. The salt is a product of flesh, and I can't really put my finger on how it turns into salt, but I'm sure it's a fairly simple process because it happens everywhere. And the salt flats are if you look at when the water hits the salt flats, that is skin cells, and I'll show you some pictures of that in a minute. But you can see that something is causing the flesh to turn into salts. And of course, there's not just salt there. There's all kinds of minerals, and the same things that is in your other bodily tissues, which is the what do you call them? The transition metals and all of the trace elements. So that's what you need to be healthy, and that's why the Dead Sea salt that's the very lowest spot, and all the stuff ran off to that from creatures that the salts eroded from their body and were expelled, and then they collected in the Dead Sea salts. That's what they used to make ormus, which is highly enriched minerals inside of these salts, and it's very good for your body, and for everything that lives needs these metals and minerals to transfer things in your blood. That's what they do. All right, I just happened to catch this on the web. I'm not sure where this came from. I think it might even be Brian Forrester, who is doing fabulous work out there exposing things that need to be seen. He's not making any claims about anything, really. He's just saying, what is this? What is this? What is this? And that is what we need to do. Start by asking the questions. Now, Mud Fossil University went a little further. We try to prove everything that we're going to claim, and the claims are extreme, but the proof is extremer. It sure looks like the salt flats, except they're not pink anymore. These kind of patterns are everywhere on Earth and not explained and ignored. Okay, in part 2 of this, now that I've shown the biology that I believe is the geology that is spoken of, we are going to go and investigate the Great Lakes. And they have drained the Great Lakes in a computer simulation, and I want this guy to explain what's going on here.
Fast forward to the present day. We can reveal the evidence of the glacier's effect on Superior's lakebed only because it's been surveyed in great detail. Modern technology gives us the ability to see through the water column. Nigel Watrous and his team from the Large Lakes Observatory in Duluth use side-scan sonar and multi-beam devices to map areas of Lake Superior.
Basically a ridge running this way.
Since sound travels easily through water, it can pierce the depths of even the deepest part of Superior to uncover its shape and size in amazing detail. Reflected gives us the ability to recreate the deepest part of Superior in lifelike realism.
Okay.
At 400 meters...
We're going to go through this, and I am going to explain what I believe we're seeing on the the Great Lakes, on the floor of the Great Lakes after they drain it, and the certain topography and the mineral deposits and how the sand got to where it is and all the colored rocks and all the different things and all these different structures. How I think I can explain a lot of this, and I believe what they are, their explanations are somewhat lacking, and we'll just see where it goes from there. All right, so that is going to be the next part of this investigation of our true Earth. Now, I would like you to comment on this video, whether you like it or you don't like it, an up or a down, and make sure that you share it with people, because this is not being shown to anyone really. It's not being understood as it should be. So that's all I'm trying to point out. All right, thank you. All right, I'm going to try to make this simple, and it is simple. There's chemistry to you and me and every creature. Now, in your skin is silicon. Silicon is 50 times more dense in skin than it is internally in the tissues. And obviously there's no bones in skin, so there's very little calcium. So what do we have here for sandstone? You see this red? The red is silicon. Silicon is silicon dioxide. Sand. Sand, it's beach sand. The reddish looking sand, because it has a little bit of blood and stuff in with it too. But the sandstone is primarily silicon, and silicon is 50 times more dense in your skin than it is in any other part of your body. So that is what is presented to the environment, and it has to be tough, and silicon is tough as hell, and it's 50 times more dense in your skin than it is in any other part of your body. See mudstone and limestone. Mudstone is the fleshy part, limestone is the connective tissues and stuff. Now, these are the other items. Well, there's no bones in sandstone, so you look over here and you say, well, this green stuff, there's hardly any of it. See the green here? There's hardly any of it. And there's hardly any of it here. You see? So this is your skin, and it erodes, and that's what is in sandstone. It's eroded sediments, because that's the skin. Now, after that erodes away, you end up with the mudstone, and that's where the mud fossils are. That's what I work with, is the mud fossils primarily. Now, you see the silicon's gone. There's no silicon. There's no silicon in it because it was on your surface of your skin. Now, the other things are in here, and there's some bones in here. See the green? Calcium is kind of high up here. There's a lot of that in the mudstone. And all of the other minerals and metals that are in your body, that provide your body, and that's in the mudstone. That is the flesh. All right. Now, then we go to limestone. Limestone is what? It's connective tissue, CaCO3, calcium carbonates. In addition to the calcium carbonate, because calcium carbonate is also in seashells and so forth, and marine creatures, but it is not the same as the calcium carbonates that are in porphyritic basalt limestones. And that, they say, oh, basalt isn't the same as limestone. It is. It's the same thing. They just make names for all this stuff. Trust me. CaCO3 is calcium carbonate from connective tissues, which are in everybody's tendinous connective tissues. There's kerogens and collagens and so forth, and they they construct limestone in your body. So, and you can see that the silicon, there's not much in here. There's all kinds of, there's not all kinds, but there's still some calcium. There's, the phosphates and the magnesium and all that stuff inside the limestone that makes it strong and tough. And that is what tendinous material is. It's tough as hell. And it almost never goes away. And that the whole Earth is primarily made of limestone in the structural hard things that you see on the Earth. The fleshy, muddy things and the mudstone and the earthy looking things are the mudstone, and the sandstone and sand is the eroded part of the creatures. Now that is my statement, and I will show you some more to back that up. All right, Exhibit B. You see this clay down at the bottom? Calcium carbonates at the top, CaCO3, the limestone. The more clay you have down here, mud and mudstone, which is the flesh, which is the outside, it's the muddy, it's your muscles and things. Then it starts to go up, and it adds a little more tendinous material and a bonyish stuff in there, and it keeps growing towards your constructive material that's inside of you, your structural material, the limestone, CaCO3. It's obvious. Up, down, up one, down the other. So when you start to understand this, all this stuff makes sense. And I am making sense where nobody else makes sense. So let's go from that side of it too, because all the things I am going to say, I'm backing up with 100% support. And if nobody's challenging on this because they can't. So now you have to take this and say, well, what does this mean? Well, let's find out. Let's do a little study on it, because it does have meaning. All right, here's another story here going on with granite and all these other different stones that they talk about. Igneous rock classifications, okay? You got felsic, intermediate, mafic, and all this. Now, you see what they're saying here? Granite. See, green, and this is green. It's not, granite is not even a natural stone. It's not a natural stone at all. Granite is coarse grained. That means it's crushed up into little bits and pieces, and they're big enough to be big. They're big. They're not fused together well at all. Basalt is more the volcanic basalt is very tightly grained, and this granite is granular chunks. It's intrusive. It's not supposed to be where it's found. It's because it's leftovers from crushed rock gold mining. Well, actually, they took out all the metals. Anyway, and that is what granite is. That's what it is. It's not volcanic at all. Now then they go down to volcanic, see, fine grain, because it's not crushed rock. It's extrusive. That means it comes out of the earth. It's not something that somebody's piled up on the earth. And that's these kind of things. Basalt, I agree with that. That's, obviously it's lava. But these are not. These have nothing to do with, well, these are. Anyway, it's not right at all, granite. And I can prove that.